Let's look at a couple examples using the equation for an ellipse. So for our first example, let's sketch the graph of this conic section. Now I hope you recognize that this equation is an ellipse, it just has the right form. And so comparing it to our template, since the larger one is under x squared, that means that is our semi-major axis. So x squared over a squared plus y squared over b squared equals 1. So comparing the equation we have to our template here, it looks like a squared is 25. And that means a, our semi-major axis, is 5. And b squared is 9. And that means our semi-minor axis is going to be 3. All right, so now we can sketch the ellipse. So since our semi-major axis squared was under x squared, that means our semi-major axis is going in the x direction. So starting at the origin, go 1, 2, 3, 4, 5. So there's the right-hand vertex for our ellipse. And 1, 2, 3, 4, 5. So there's the left-hand vertex for our ellipse. And then the minor axis is going to be going vertically. So that's 1, 2, 3, and 1, 2, 3. And then we can just sketch our ellipse. So it looks like this. It's hard to draw this smoothly on this tablet that I'm drawing on. Okay. Of course, this should be perfectly symmetrical. It looks like I didn't quite mark the distances the same. This right-hand point should be maybe a little further out, and the curve isn't nice and smooth like an ellipse, but close enough. All right, also, let's label all the foci and the intercepts. Now, the intercepts are easy because, those are the points that we use to sketch the ellipse in the first place. So this x-intercept on the right is 5, 0. This x-intercept on the left is negative 5, 0. The y-intercept on top is 0, 3. And the y-intercept on the bottom is 0, minus 3. But to locate the foci, we need to know the focal radius. That's the distance from the center to each focus. And that's called c. And remember, the way we have our notation set up, b squared plus c squared equals a squared. And b squared we know is 9. C we don't know yet. And a squared we know is 25. And so we can just solve this for c squared. So c squared is 16. And that means that c is 4. C can't be negative 4 because it's a distance, so it has to be positive. So that means our foci are 4 units from the center along the major axis. So that's going to be here. So there's one of our foci, and here's the other one on the left. Okay, so there's our ellipse. All right, for a second example, let's try this the other way. Let's find the equation of this ellipse, and also let's find where the foci are. So from the template for the equation of an ellipse, x squared over a squared plus y squared over b squared equals 1. Right? The other possible version of the equation of an ellipse we might want is x squared over b squared plus y squared over a squared equals 1. And which one you use depends on which direction the major axis is going. Because remember, a is the part that goes with a is the semi-major axis. And in this ellipse, right, the major axis is just the longer one. And in this ellipse, that's clearly up and down. So our major axis is going in the y direction. And so we're going to use this second version of the equation for the ellipse, not this first one. This first one is when your major axis is horizontal. Okay, so now that we have the right version of the equation of an ellipse, we can read some information directly off of the graph here. So this horizontal distance, that's the semi-minor axis, that's the short radius, essentially. And we usually call that b, and that's 2. And then the long radius from the center out to the top. That's the semi-minor axis, that's A, and on the graph it looks like it's 5. So now we know A and B, we can just dump them in here. So x squared over 2 squared is 4, plus y squared over 5 squared is 25, equals 1. So there's the equation of our ellipse. To locate the foci for the ellipse, remember we just need to find the focal radius c, and we have this relationship b squared plus c squared equals a squared. But b squared, b is 2, b squared is 4, plus c squared equals, a is 5, so a squared is 25. And that means c squared is 21. And that means c is the square root of 21, which, let's see, square root of 21, it's about 4.6, like. Remember, the foci are along the major axis, so this 4.6 is the distance from the center up and down to the foci. So it looks like our foci are going to be here and down here.